We are Shady Business.
Yeah!
Oh, woo! My name is Zoe Greco, and I am the team lead.
I'm Haley Tibbs, and I'm the design specialist.
My name is Atma Thompson. I'm the finance and communications officer.
And I'm Alan Gary, the CAD specialist.
So this is our iterative design process. Currently we have just finished the conceptual design stage and plan on moving on to the detailed design stage.
Phase 1 is project identification. The purpose of Shady Business is to create a comfortable passage for students, faculty, and Tempe residents between ASU and the Mill Avenue district by designing a multi-purpose shade module. We want this shade to look aesthetically pleasing. We want it to be heat repellent as well as resistant material. We want it to be low maintenance and weather resistant.
So this is a map of where we plan on putting our shade module, outlined in gold. And as you can see, it is on 6th Street, which is just north of the new College Avenue building, and it is to the east of the Tempe City Hall and ASU Brickyard.
Stage 2 is specification development. In a survey, 9 out of 10 people down 6th Street said they would prefer a shade when they were walking down the street. People are more likely to walk in an area where shade is present, so it's also a safety factor for ASU. Students are more likely to walk under the shade rather than crossing the street and jaywalking. Tempe is also looking for functional art, so looking for different districts around Tempe, and we also want it to be aesthetically pleasing with an urban forest. Some research that we are going to discuss is the cantilever design, which is in our past experiments. Our lily pads of shade, consistent shade, not fully connected, and shade that covers longer paths with less material.
In previous semesters, we have designed and redesigned to get where we are now. In the past, we have made designed and redesigned to get where we are now. In the past, we have made a leaf structure that attaches to a post and is able to cover the sidewalk. We have also have an umbrella design that opens up and closes in day and night and is able to do functions of day and night. We have a corridor structure that covers the entire sidewalk, and we had lily pads of shade, which are different lily pads of shade that go throughout the sidewalk, and we are currently on our cantilever design, which we have decided to implement as our final design. Okay. This semester we have completed stage 3, the conceptual design. We created 3 different shade shapes: triangular, kite, and sun.
Our first design is a classic cantilever made out of 2 isosceles triangles. It's wide in an effort to maximize shade projection lengthwise across the sidewalk. Each of our 3 designs is offset in the center and split in order to allow for water, wind, and debris to pass through. Our second design is a kite shape. It's made out of 2 scalene triangles and is long and narrow in an effort to maximize shade projection widthwise across the sidewalk. Our third design is meant to look like a sun. It's made out of 2 semicircles with 3 equilateral triangles at the ends. This ties into the City of Tempe's plan for districts, so this would be the ASU Campus District shade.
In order to choose our design, we used the lamp track that was built by Dr. Zhu and Trowbridge for their FSC 100 classes. This involves a lamp that follows an arc-shaped track over the course of about 2 minutes. We would let it run for a set amount of time, pause it, and mark where the shade projection was. Because of this experiment, we chose design number 3, the sun shape. The fact that it was mostly circular meant that it had the most even shade distribution.
So after completing the welding and ironworker, as well as the bending classes at Tech Shop, we had the skills to construct a scaled prototype out of materials we planned on using for our full-size shade.
After building many rough proofs of concept, we finally built an actual prototype this semester. We went to Tech Shop and we used real materials, steel, aluminum, and our nylon ripstop fabric to build this prototype. We attempted to make the sun shade, but we're not able to attach the triangular parts. They can be attached later in fabric strips, but not with an aluminum frame like we expected. So we're calling this one the half moon shape, and its scale is 1 inch to 1 foot.
These are the decision matrices we used in previous semesters to decide on the materials and shape of the structure. We also included a section for extra features in case we wanted to include those after the actual structure itself has been completed. So for our materials for the scale model, we are using UV-resistant ripstop nylon fabric for the shade material itself, which was purchased last semester. Steel and aluminum for the post and shade frame, both of which are recycled materials from Tech Shop. And for the scale model, we are not including the steel cables, but they will be included after the force analysis, which will take place in following semesters.
So this is our budget for our current and previous semesters. As you can see, we included the Tech Shop classes as well as the cost of an aluminum post. So apart from presenting our scale prototype to our community partner, which we plan on doing on the first week of May, we have completed everything in our implementation plan for the spring semester. We planned on taking 3 Tech Shop classes originally, but we only did the welding and the ironworker and bending classes because we did not need to take the industrial sewing class due to hand sewing our scaled prototype. We also did not need to order more materials to fill out our funds request forms because we created our prototype out of recycled materials provided by Tech Shop.
As we mentioned earlier, this semester we have completed Phase 3, Conceptual Design, and next semester we will be moving on to Phase 4, Detail Design. In that phase, we're going to need to develop design specifications for the components, which would involve creating exact dimensions for the prototype and updating it in SOLIDWORKS. Next, we're going to do design failure mode analysis, which includes failure scenario analysis and force analysis. Based off this information, we will refine our prototype and determine new materials and create a new budget in order to build another one at Tech Shop. Let's get down to business to defeat the sun.